We start on the agent dashboard. This page shows a high-level operational view of AI agents running in production. At the top, we see summary metrics: number of agents being monitored, high-risk agents that require attention, average error rate, average tools used per session, number of events per session, unique tools per agent, and alerting sessions. These are behavioral signs, not just prompts, meaning also is tracking what the agent actually does, not just what it says. Below is the event volume graph. This shows action frequency over time for a specific agent. A spike here indicates a possible loop, prompt injection, or misscoped automation, what this system calls a velocity anomaly. So this page generally answers, are my agents behaving normally right now? Now we hover over the spike in the graph. This represents a burst of tool activity from an agent session. In Oso's model, abnormal action frequency is one of the earliest indicators of misbehavior, before a real accident actually occurs. The system is detecting behavior drift rather than waiting for a failure and alerts you. We scroll to tools by risk score. Each bar is a tool the agent has used and ordered by risk level. Red means high impact actions, yellow means medium, and green means low. The risk score is derived from what the tool can affect: file system writes, external communication, state changes, and more. This lets operators immediately understand if the agent goes wrong, what damage is possible. If we hover on a tool and see which agent used it and its risk qualification, then we can impact the behavior and the potential blast radius. We moved into alerts. Now we're seeing actual trigger detections. These are generated by policies evaluating executed actions. Some examples shown are risk threshold exceeded, so too many risky actions in a short time, phone numbers detected in tool response, and phone numbers detected in prompt. These are not just heuristic guesses, but they're based on observed tool calls and content inspection. We open the phone numbers detected alert. Here we see trigger frequency and history. This is action level evidence. This alert exists because the agent produced sensitive data, which is a classified content. Operators now can determine whether this is a legitimate workflow, data leak, or prompt injection. If you open the activity, you can see a chronological event stream. This would include the user prompt, tool request, tool response, and the agent response. Each entry is tied to the session, agent, and the user, and it creates a debugger for agent behavior. You can open a specific session to see the full context. On the right is the full interaction and prompts and internal workflow descriptions, while the system links them to actually executed actions. This allows comparing the stated intent and the actual behavior. If you open agents, then you can list all discovered agents and the tools each one has used. Important point here is that these tools were not manually configured, they were observed. So the system learns real permissions rather than assumed permissions. Now we open integrations. Here we see group tools by system, Notion, Linear, IDE, etc. Each tool shows which agents use it, the status, and the risk level. If you open risk settings, then you can see the system and how it automatically alerts when behavior exceeds defined thresholds. Here you can create predictable failure modes, so instead of runaway agents, you can have controlled escalation and you can do automated containment. Finally, we open content controls. Sensitive data categories like credit cards, phone numbers can be enabled and disabled. Here you can prevent data exfiltration, not just detect it.